Welcome to the Pioneer training video for the calculation of takeoff and landing performance data in the British Aerospace 146. This video will step you through some worked examples calculating takeoff and landing performance cards based on the method developed in the Standard Operating Procedures Manual, Issue 4. So as you've already gathered, this video demonstrates the preparation of a takeoff and landing data card for landing. To follow along, you're going to need at least the landing side of the new format takeoff and landing data card, access to the engine thrust reference table card. You'll find that on Comply 365. Of course, the speed cards. We're in a 300 series today. Finally, you're going to need an FMS and a TMS. And yes, I'm kidding. That said, if you want to know how to set up a 146 simulator on your home PC, give me a call. Let's move on, shall we? So here we are contemplating an arrival into Townsville in a 300 series 146, just the two of us. Townsville is giving Cabo K 24 degrees 1015 with a wind of 060 degrees at 20 knots, gusting to 30 knots. Our zero fuel weight from Brisbane was 26,765. Time to get to work on the card. So our landing card already has the zero fuel weight on it from the load and trim sheet when we prepared the takeoff card. If not, we grab this from the LTS just to make sure it's correct. We can start the card by completing the identifying strip across the top, including the bay if we had one. And finally, let's stick the ATIS in the weather box as well. So now we're going to look at the go around N1 and the speed increments. Before we look up the N1, we should decide that we won't need engine ice for the go round. Our go round N1 comes from the engine thrust table card, in this case the pink card for engine anti-ice off. We need the temperature on the ground from the ATIS and the pressure altitude. And so we end up with a go round N1 of 92.4. Let's write it on the card. So now let's look at the wind and calculate a gust factor. While we're here, let's recall that if we suspect we'll have airframe icing present for the approach, we also add 7 knots to all the speed bugs, and any combination of gust and ice factors is to be limited to a maximum of 14 knots. So half the variation in wind speed from any direction to a maximum of 10 knots. So 20 gusting 30 gives us 10 knots of variation, half that into 5 knots, and onto the card it goes. Remember that while the icing factor is added to all bug speeds, the gust factor is only added to V approach and V rev. It's now time to get the Airways clearance onto the card. We're heading for runway 01 ILS in Townsville via the POROB 1 Alpha arrival. So a suggested method for top of descent calculation is 3 times the height loss required to your most critical star constraint or the destination, and adjust that distance 5 miles for every 20 knots of consistent head or tailwind component you estimate down the descent. And so in this case, we're aiming for 11,000 at POROB and a 20 knot tailwind between top of descent and POROB. Right, time to move on to fuel over destination. We can start with the FMS fuel overhead figure, but give a thought to any odd inputs that might affect this estimate, remembering that it's based on your current ground speed, fuel flow, and the flight plan to your destination, including perhaps one of those 50-mile vectors Universal seems so fond of. As part of your fuel planning for arrival, the reserves figure in the FMC might need updating to account for any possible alternate planning. Set a figure that will give you plenty of warning for that point at which the FMS believes you're running low on fuel relative to your destination. Now let's have a look at hold time. Right, so moving on to hold time and minimum divert fuel. While there are holding tables in the FCOM for both flaps up and flaps 18, along with corrections for ISA deviations, a figure of 1900 kilos an hour seems a reasonably conservative figure to base your holding estimate on. And so in this case, assuming we've set our reserves correctly in the FMS, we can take our excess of 3300 and divide it by 1900 to get 1.7 hours. If you're planning on holding an alternate, then calculate a conservative min divert fuel based on your flight plan to the alternate and any margin you care to add. The requirement to plan for an alternate will impact your available holding time as well. Okay, we're almost done. On to the landing weight and V-speeds. So, landing weight and V-speeds. To select speeds, we need a landing weight. From our card, landing weight is equal to the zero fuel weight we completed during pre-flight, which hopefully hasn't changed, and our updated fuel over destination. So in this case, that's 31 tonnes on the toll card. So that makes selecting a speed card pretty straightforward. We'll go with the standard flap 33 landing, and we get a speed card VREF of 108 knots. Now we have to apply the increments. We've already calculated gust factor as 5 knots. In this case, our icing factor is 0. So our VREF becomes 108 plus 5, that's 113 knots onto the card. V approach is speed card VREF plus gust plus ice plus 5 knots. In this case, let's write 118 knots on the card. V maneuvering, which in this case for a flap 33 approach is the flap 24 maneuvering speed, we add the icing increment, which is 0, but not the gust increment. Therefore, today it's just the speed card VREF plus 20 knots to get us to flap 24 maneuvering, and onto the card it goes. Finally, VFTO once again comes straight off the speed card. Only the icing increment is added, which in this case is 0, so it's 159 onto the toll card. And last but not least, VAR comes off the speed card. Once again, we add only the icing increment and then bug it on the ASI. VAR should always be 10 knots above the toll card and bugged VFTO speed. With the card complete, it's time to hand it over to the other pilot for an independent cross-check. While this procedure is covered in the SOPM, the following points are worth noting. Cross-checking is a skill that, first of all, requires the knowledge and understanding of how the card was completed in the first place. You can't cross-check a card if you don't know how to prepare one yourself. So with the landing card complete, cross-checking requires you to consciously avoid or look for prejudiced information. This includes looking at the ATIS yourself, the FMS, the flight plan, thrust cards, speed cards, or yourself. In all cases, finding the correct page rather than accepting a previously selected page by the other pilot where that requirement is relevant. In some cases, both pilots might need to look in the rack manual for any limited landing performance case. So with cross-check done, before you hand the card back to the other pilot, independently set your speeds. When the card is returned to the other pilot, he or she should also independently set the speed bugs, at which point the N1 bugs and the airspeed bugs cross-check can begin. And we're done.